Electric locomotives have been providing hauling power for trains since 1837. Unlike steam and diesel locomotives, electric locomotives do not carry any fuel or energy source. The energy that drives them may be located hundreds of kilometers away from the locomotive itself. Electricity produced at a distant power station is conveyed to the locomotive through overhead catenaries. An electric locomotive is essentially a box full of transformers and semiconductors. A pantograph collects electricity from overhead wires and transfers it to a transformer, which sets the electrical power to the desired voltage. A connection with the axle brushes completes the circuit. From the transformer, the alternating current drawn from the overhead wires is transferred to a main rectifier, which converts it to direct current. The main and auxiliary inverters convert the direct current into three-phase alternating current. The three-phase alternating current powers the traction motors, which then drive the wheels. For the traction motors to efficiently drive the wheels, many small but important components are also needed. Auxiliary inverters and rectifiers power these smaller components. Transformers and rectifiers produce a lot of heat and have to be kept cool. This important job is done by cooling fans, which are powered by the auxiliary inverter. A compressor, also powered by the auxiliary inverter, supplies air at the required pressure to operate the pantograph. A battery provides the power for startup operations and also supplies essential circuits. The battery is usually connected across the DC control supply circuit. Finally, the traction motors also produce a lot of heat and require cooling. The traction motors are cooled by separate cooling fans, which also draw their power from the auxiliary inverters and rectifiers. So that's how electric locomotives work.